Okay, so this unit finishes off with three compound measures, and the compound measures are density, speed, and pressure. So density is going to tell us whether or not one substance floats on another substance. Speed tells us how fast something is going, and pressure tells us whether or not the surface that something is resting on is likely to break. So these are really, really important measures for physics in particular. And you'll see that all three of them are very similar, with the questions varying slightly from one to the other, but the techniques are identical. So let's just make sure that we understand the definition of density. Density is the mass of every unit of volume. So it's a mass, and it can be measured in kilograms or grams, for a unit of volume, which is either measured in meters cubed or centimeters cubed. So for the first question, we're told that 300 cubic centimeters of gold weighs 2.4 kilograms. Calculate its density in grams per centimeter cubed. So the way we're going to do this is we're going to set out the information that we're given. We know that 300 centimeters cubed is equal to 2.4 kilograms. I'm going to change that to grams, is 2,400 grams. Going back to our definition, density is the mass for 1 unit of volume. So it's asking us, how much would 1 centimetre cubed weigh? Well, we should be able to see, if I want to go down to 1 centimetre cubed down here, to go from 300 down to 1, I'm dividing by 300. So if I divide by 300 on the left, I've got to divide by 300 on the right. 2,400 divided by 300 gives me 8 grams. 1 centimetre cubed equals 8 grams, so the density is 8 grams per centimetre cubed. And that's the density of gold. Let's take a look at number 2. Oak has a density of 1.4 grams per centimetre cubed. Calculate the weight of a 10 centimetre cube of oak. Okay, well let's start by having a look at what we mean by a 10 centimetre cube. So if I've got a 10 centimetre cube, it's 10 centimetres, 10 centimetres, 10 centimetres. So it's a block that looks like this. What I want to know is how much does that weigh? Well, the first thing we're going to need to do is work out the volume. So the volume of the face here is 10 times 10, which is 100, times by 10 is 1,000. So volume is 10 times 10 times 10, which is 1,000 centimetres cubed. Now we can start answering our question. I know that 1 centimetre cubed weighs 1.4 grams. That's what that density means. I want to know what 1,000 centimetres cubed weighs. So I'm going to have to do 1 times 1,000 times by 1,000 over here. 1.4 times 1,000 gives me 1,400 grams, or 1.4 kilograms, whichever way we want to put it. Let's look at the third question. Mercury has a density of 0.8 grams per centimetre cubed. Calculate the volume of 72 grams of mercury. So, again, I can say 1 centimetre cubed weighs 0.8 grams. I want to know what 72 grams would be. Well, this is a bit more difficult, and the way we do this is use the unitary method. So I'm going to put in a middle step, which is going to be to find out what the volume is of 1 gram. Well, what can I divide by to give me 1? Well, anything divided by itself gives me 1. So I'm going to need to divide by 0.8. 0.8 divided by 0.8 is 1, and then times by 72. So I'm going to have to do the same on this side. 1 divided by 0.8 and times by 72. Let's just do that on our calculators. 1 divided by 0.8 times 72. It gives me an answer of 90 centimetres cubed. So there's my solution. Okay, pause the video now while you write down those worked examples. When you're ready, press play and we can go on to some questions of your own. Okay, so there's 7 questions here for you to try. For the first 2, you're trying to calculate the density, so remembering 1 unit of volume, what's its mass. For questions 3 and 4, you're trying to calculate the weight. Question 5, you're trying to calculate the volume. For question 7, it's a complex question that you would see towards the end of the paper. So the first thing you need to do is calculate its volume. Once you've calculated its volume, you need to work out what that missing length must be to give you that volume. Okay, pause the video now while you have a go at the questions. When you're ready, press play and we'll look at the solutions.